Good morning. Today we are going to discuss other part of the module, fifth module, nanomaterials. So what are nanomaterials? Nanomaterial or a nanometer. So what do you mean by nanometer? Nanometer is nothing but a billionth of a meter. Just imagine how tiny or small is a nanometer will be. So nanometer is a billionth of a meter, 10 to the power minus 9 m is called as nanometer. So that fine structure, that fine particle is called as nanomaterials. Nanomaterial invention has been given a very good development in technology, maybe to televisions or mobile phones or you name anything, nanomaterials have contributed to that particular thing. Okay, so now let us see what nanomaterials and how the nanomaterials can be synthesized using various methods. So as discussed, nanoparticles are 1 and 100 nanometers in size. So nanotechnology, a particle is defined as very small and a fine object. So coarse particle cover a range between 2500 and 10,000 nanometer, and fine particle core size range between 100 and 2500 nanometers. So nanoparticles can be synthesized by salt gel method, precipitation method, and chemical vapor condensation method. So we'll discuss how to synthesize the nanoparticles method by method. To start with, we'll start with salt gel method. So salt gel method, this is an important bottom approach for synthesis of nanomaterials. So in salt gel method, following steps are involved. So first we're going to prepare the salt. Preparation of salt is the first method. Next, conversion of salt to gel. Next, aging of salt and removal of solvent, and finally it is heat treatment. There are different steps. The first step is preparation of salt. Secondly, conversion of salt to gel. Thirdly, aging of salt, removal of solvent, and finally it is heat treatment. The salt gel process has been mainly used in synthesis of monodispersed nanoparticles, metal oxide, temperature sensitive organic, inorganic, hybrid materials. We'll see what are different types of nanoparticles which are synthesized later. So let us see how to prepare nanoparticles using salt gel method. So inorganic salt, let us take any inorganic salt. Initially it is preparation of salt. So you're going to take any inorganic salt, it will be dissolved in water or a suitable solvent to make a homogeneous solution. This homogeneous solution is hydrolyzed using water or alcohol in presence of acid or base to convert into salt. This is second step, conversion of salt to, conversion of or preparation of salt. So now we're supposed to convert salt to gel, isn't it? So now we're supposed to do polycondensation. So now gel is obtaining by condensing the dispersed colloidal particles into gel. That is, gel is interconnected into a rigid and porous inorganic network enclosing a continuous space. So this transition of salt gel occurs. So the condensation reaction continues until gel transforms into a solid clusters accompanied with contraction of gel network and explosion of solvent from gel pores. You can see the polycondensation reaction, that is between alcohol and this MOR. You know what is MOR, isn't it? It is the ligand here. Results in the formation of an oxide or alcohol. This is a gel. Next process is aging of gel. So the reaction mixture is allowed to continue the polycondensation reaction until gel transforms into mass solid. For how many days it will be allowed? So it will be allowed. It is the aging process, minimum it takes more than 7 days, and is critical to prevent the cracks in the gel that have been cast. So the liquid is removed from the gel, that is the next step, and it will be allowed, the liquid will be allowed to evaporate and will be allowed to dry. The sample that is obtained is heated to obtain nanoparticles. So you can see this is a precursor. It will be dissolved to form a salt and it will be dehydrated to form a gel. So once gel is formed, it is allowed for aging process. So once aging process is completed, next you are going to do heat treatment not to remove all the solvent particles. Once all the solvent particles are removed, then it will be heated to get the nanoparticle. This is how we're going to get salt nanoparticles by salt gel method. So cadmium semiconductor nanoparticles or nanocrystals is obtained. Titanium oxide nanorods are prepared by salt gel method. So what are the advantages? So nanomaterials of high purity with good homogeneity can be obtained by salt gel method. So shape and size of the materials can be controlled. Easy to control synthesis parameters to control physical characteristics like shape and size of resulting materials. Samples can be prepared at low temperature. So these are the major advantages of salt gel method. So in our later discussion, let us see how to synthesize the nanoparticles by vapor condensation method and precipitate method. Thank you.